linear. So now if that rotates around there, that line will always remain collinear to it. So you can do that.
Cool. Yeah, let's go through. We'll apply quite a few of these. So I want the flange edges to be collinear. I want these edges to be collinear. I also want the bottoms to be collinear as well. So we can go through and I can make these bottoms collinear as well. So we'll make that one collinear with that one as well. Cool. It's looking a bit better, Ian. Anything else I could do?
Yeah, you could call them arcs equal. I've already shown that, so I'm not going to do that.
No problem. So there's the equal. One other option is if I right click, I can choose multiple points, so I don't have to keep doing the same. And I can select the first one and make them all the same as that first one that I clicked. Just zoom in and select that one. Press enter. Okay, hey, it's looking a bit better now. Anything else, Ian?
Getting there. It doesn't look very symmetrical to me, so we could use symmetrical. Let's go and show you some symmetrical stuff. If I draw myself just a circle there and another one there, I'll just draw a line down the middle, like so. If I use the symmetrical one on that circle and on that circle, and using that line of symmetry, you can see what's happened. You know, the circles have remained there. And if I move one circle, the other one will have to move with it. If I change the circle's radius, the other circle will change its radius too.
Cool. Right, so let's make them symmetrical. So let's make the web symmetrical around the construction line. And let's also do the same with the flange edges. Okay, so it's looking a bit better now. I did notice yesterday, though, Ian, when I was doing this, that it doesn't really have a fixed point, and I thought it might have been useful to have maybe a start point where this object's going to be placed from.
Yeah, you can use fix as a bit like a base point in your blocks. Let me show you. If I go back to my tangent circle, do you remember when I moved that line, the circle moved with me? Yeah? What I could do, if I fix the centre point of that circle there, and I move the line, what's going to happen? Well, it's fairly obvious, isn't it? The only thing that's not constrained is the radius. So if I move the line now, the circle centre point stays the same, and the radius changes, yeah? So you can do that on there.
Yeah. Okay, so there's my padlock. We'll put the padlock on, and let's just fix that there. Right, there's a couple of things I've noticed that my flanges are different thicknesses, so I'm going to apply another equals. I'm going to make both the flanges the same thickness. Okay, so we've now got that set up. Now what I'm going to do is I'm going to dimension this up, but before I do that, notice that I've got all these constraints showing. It's a little bit messy, it's hard to see. So I'm just going to hide the constraints, okay? Then I'm going to dimension this up.
Right, while Simon's dimensioning that up, there's a couple I haven't shown yet because they don't really fit with this universal theme. There's concentric and there's smooth. Right, concentric's really simple. Anything that has a centre point, so your arcs and your circles, if you make them concentric, they will share the same centre point. So in this scenario here, the circles are now constrained. If I move that inner circle, the outer circle will move with it. Yeah, so that little things like that might be useful with your nuts and bolts. Similar with arcs, if they're sharing the same centre point, we can force them to have the same centre point. And then, of course, if I move one arc, the other arc is going to follow suit as well. And again, that makes life just a little bit quicker. The next one, the smooth one's a little bit harder to explain, or I thought it was anyway, maybe because I'm a bit thick. The main thing is, I think, whenever we get this new software, we examine it, we look at it, and we learn all about it. It's all well and good knowing what the function does, and that's our first job, to find out what the function does. But our second job is then to apply that into what you do for a living. And because sometimes if it's not relevant to what you do for a living, then I ain't going to bother showing you, because developers can get it carried away sometimes. So the best scenario with this is, what this will do is it will take a spline, and it will put a smooth between a spline and another object, like a line or a polyline, or indeed another spline. So when I constrain this spline here, it will put a nice smooth between it, and if I move that one, that smooth will continue to develop and move with the other one. And the best example of that is when we're doing contouring in mapping. We often use splines, and if you were to remove all the text, you end up with a gap. What you can do is use a constraint to join up all them gaps, and then when the surface changes, everything else changes as well.
Right, well, here's my I-beam, but if I sent this off to Chorus, they'd probably laugh at me. If only I had all the universal measurements and sizes that I could program into this.
If only. It's like
we've
done this before.
Have we rehearsed? Well, we can. Now, obviously, I could go into each of these dimensions like you've been showing you double click in them, change the dimension. But we actually have this parameters manager here. The parameters manager contains all the parameters I've set up, so flange, height, radius, web width, and I can just simply come into here and change them. So let's change these to be a proper standard. So the flange is going to be 15.5.
Notice I've highlighted the ones that, sorry Simon, that Simon's doing on my screen there, so it's a proper size it's going to make this.
So it's automatically changing it in the drawing. The height is going to be 750. The radius is 16.5. Amount of times I've drawn this, I should know these numbers. The web is 12, and the width is the awkward one because that's 264.4. There we have a fully constrained, standard size, universal beam. Ian, could we possibly use that same LT?
Of course we can. Here we go. Here's your AutoCAD LT on my screen now. If I go to the parametric thing, the first thing you'll notice is a cut down ribbon, because in LT you can't actually make the parameters, you can't do the constraints in LT, but you can work with them. It's a bit like when they introduced dynamic blocks. You couldn't make them in LT, but you could work with them. So it might come in the future, I don't know. The first thing is, obviously, you can switch them on and off in here. It is constrained in exactly the same way as Simon showed. So if I change that to 1000, the whole lot's going to change. Yeah, we've got the parameters manager here, and I can change it in there in exactly the same way. Okay, so we've got full control over there. We can show them all, we can hide them all, and indeed we can delete them all as well. And if I do delete them all, it just becomes a bunch of lines. Alright, so you still have that control in LT.
Cool. But we can take this all a little bit further now, and we can maybe make a dynamic block out of it. Now, there's nothing new about dynamic blocks, but let's just go to our insert and let's just create a new block. I'm going to call it I-beam, and pick my base point. So we'll pick the same one that I locked. We'll select the object. It's going to be everything there. Okay. Press enter. Okay. There's my beam. You might all notice that my dimensions have disappeared. If I click on it, I just have the base point. So let's go into the block editor and see what's happened. We go in here and notice that all the dimensions are in here, but these are parametric dimensions. We need to change them to block dims. So what I'm going to do is I'm just going to simply delete that dimension and let's change it to a linear block dimension. There we go. There's my dimension. Default value, number of grips. I'll just have one grip. There we go. Notice it's renamed it. I don't like that, so I'm going to change that back straight away before I forget. That's a height. Okay. Now, if I wanted to test this block previously in early releases, I would have to save my block, start a new drawing, insert the block, play with the block, find out that I've missed all the other dimensions off, go back into the block editor. We've now got this cool new button, Test Block. Click on it. It takes you straight into an environment where you can test out how your block's working. Yeah?
That's a top tip, that one. I love that one. So that test block, for those of you that make blocks, that's going to save you a lot of time. So that's my next productivity thingy.
Cool. Now I don't want to delete all these dimensions and replace them, so I can actually convert them. We actually have a convert tool up here, look, so I can convert the parametric dimensions straight into block dimensions. Now if I wanted to change number of grips on this dimension, dead easy. I can right click, go to my properties. Here's the properties, change that to 2 grips for the web. And now look, I've got 2 grips in there. Okay. Next thing I might want to do is there was a lot of information on that list that Ian had.
There is.
Oh, cool, excellent. There's a lot of information there, so it might be nice to add some more of that information into this. So let's add some more definitions, so attribute definitions. I'm going to add a new one called, the first one is called,
Designation.
Designation.
Simon's just going to add in the, the extra information beyond the dimensions that are on this table here. So we've got all
There's designation.
Information.
We'll have one in there called mass. Little top tip. Click that button there, a line below previous. Don't have to worry about locating it correctly. And then the last one I'll have is depth. Okay, so there's my depth. And let's add a block table in here as well. There's my block table. Let's place it down here. 1 grid. Let's add in all them fields that we've just created, so the measurements and the attributes. We'll stick them in. Okay. Right, I need these in the same order that you're listing.
Yeah. So we've got designation, then mass,
Yeah.
then height,
Yeah.
width,
Yeah.
web,